to the channel. Today I'm going to be reviewing everything that I've taught you about addition all year in one video. This might get long. We should probably get started. The first piece of advice I have for you is to use correct terms. It's important to use the correct language when you're describing a math problem, especially if you have a question. The more precise you can be with your question, the more precise your teacher or parent can be with their answer. When you add numbers, the amounts that you're adding are called addends. In this problem, there are only 2 addends, but in addition, you can have as many addends as you want. 3, 4, 10, 100. There's no limit to the number of addends you can have. The answer to an addition problem is called the sum. There should only be one sum to your addition problem, and that's the total amount once you've added all of the addends together. My second piece of advice is to understand the concept. A lot of times teachers will talk about number sense, and this is your ability to really understand what's happening with numbers. When you add numbers, you're taking 2 or more amounts and you're putting them together. Because you're putting those amounts together, your sum must always be greater than your addends. That might seem like a simple idea, but it's actually pretty sophisticated. Let me give you a question that illustrates what I mean. Here are 3 pretty tough addition problems. I want you to tell me which of these problems is false, but I'm only going to give you 10 seconds to figure it out. Go ahead and get started. "10 seconds isn't a lot of time, but you should have been able to tell right away that choice A was false. Here's why. 84 is a greater number than 97.
Hi guys, during editing I realized I said that 84 is greater than 97 and I meant that 84 is less than 97. I blame Bitey for distracting me. Alright, let's get back to your video.
If you take the number 97 and you add more to it, your sum is going to be greater than 97. 84 is less than 97, so right away I should be able to look at that and know it's not correct. You should also be able to look at your sums, and if your sum is actually less than one of your addends, you haven't done it properly and you need to double check your work. My next strategy is to use your fingers. A lot of teachers and even parents will tell kids not to use their fingers, but why not? The fact that we have 10 fingers is why our entire number system is base 10. The only problem with using your fingers to solve addition problems is that if the sum is going to be greater than 10, you're going to run out of fingers. My next strategy is to use a number line. You can print a number line from the computer, you can get one from a teacher, or you can make your own just by writing the numbers from 0 up to 20 or 30. But my favorite kind of number line is a ruler. I like these because they don't get bent and folded and ripped the way that paper number lines do. Also, a ruler serves many purposes. You can use it as a number line, you can use it to measure things, or if you're drawing, you can use it to create straight lines. Let me show you how to use a number line.
This problem says 7 plus 6. The first step of using a number line is to look at the first addend and then point to that number on your number line. So this is a 7, so I'm going to point to the number 7. The next step is to look at the second addend, which in this case is 6, and to move my finger that number of times. So I'm starting at 7 and I'm going to move my finger to the right 6 times. 1, 2, 3, 4, 5, 6. I have landed on the number 13, which means that 13 is the sum to the problem. What do you think? You agree?
My next strategy is to use a hundreds chart. I will leave a link in the description box below to where you can find a hundreds chart, print it out, and use it to help solve math problems. Let me show you how.
This problem says 57 plus 8. The first step is to look at the first addend, which in this case is 57, and to place our finger on that number. Our next step is to look at the second addend, which is 8, and to move our finger to the right this many number of times. If we get to the end of a row, we're supposed to go to the beginning of the next row and continue. So here's 57. Let's move 8 times. 1, 2, 3, 4, 5, 6, 7, 8. I've landed at the number 65, which means that 65 is the sum to the problem. Is that good, Bitey? You agree?
My last strategy is to look for keywords. Here are some keywords that tell you to add: sum, together, all together, in all, or. Now, you do have to be a bit careful with keywords. What I see students do sometimes is they'll notice keywords in a problem like in all, and they'll automatically take every number that they see and add them all together. And that's not always what you're supposed to do. Let me show you a couple of examples where you will see these keywords, but you might not be adding the two numbers together in order to solve. The problem says, Hoppy had 7 berries. Alice had some berries. The rabbits had 12 berries in all. How many berries did Alice have? Like I said, a lot of kids would look at this problem, see the keywords in all, and automatically add 7 plus 12 for a sum of 19. In that case, I would ask that you remember tip number 2, which is to remember the concept. How can Alice have 19 berries if the rabbits only have 12 berries in all? If Alice has more than 12 berries, that doesn't make any sense. And so that kind of alerts you, that's not right. We have to go back and we have to work a little bit more carefully. Let me go ahead and write a number sentence to show how to solve this problem. Here are the 7 berries that Hoppy had. Alice had some berries, but we don't know how many, so I'm going to go ahead and leave a blank for her amount of berries. We do know that the rabbits had 12 berries in all. Those keywords in all tell me that we're adding, and they tell me that the sum or answer is 12. So now I can see that we're not adding 7 plus 12, we're saying that 7 plus some unknown amount is equal to 12. And at this point, I could use my number line, my hundreds chart to solve the problem. I'm going to go ahead and use a number line.
Here's the number 7, which is the amount of berries that Hoppy has, and here's the number 12, which is the amount of berries that the rabbits have together. I'm going to move my finger from 7 to 12. However many times I move my finger, that's the amount of berries that Alice... Really? That's the amount of berries that Alice had. So here's 7. 1, 2, 3, 4, 5. Alice had 5 berries. Yes, thank you. You're a good helper. I appreciate that.
So now we know that the amount of berries that Alice had was 5. This next problem says, Miss Noel had 2 boxes. She put 5 books in each box. How many books did she put in all? Again, a lot of kids are going to see those keywords in all and add 2 plus 5 for a sum of 7. But let's draw a picture and see what it shows us. Here are my 2 boxes. I put 5 books into this box, and I put 5 books into the other box. That's not 7 books, that's 10 books, because we're not adding 5 plus 2. What we're adding is the number 5 2 times. 5 plus 5 is equal to 10. So keywords are really helpful, but just understand they don't always mean that you're going to take the 2 numbers and add them together. Sometimes it means you have an addition sentence with a missing addend, and sometimes it might mean that you are adding repeatedly, like in this problem. I hope that this video helped you to review all the addition strategies we've learned this year. That's all I have for you today, but I will see you in my next video. Bye for now.